Anyways, I'm also very honored to introduce our luncheon speaker. I've known Dan for quite a while. Dan Frieberg is the owner of Premier Crop Systems. It's a data analyzing collection software company that's been here in the Des Moines area for nearly 20 years. They put out some outstanding software, and they work with growers throughout the Midwest, collecting, analyzing, and using data to make good agronomic decisions. So he's going to share with you, I know through a lot of the breakout sessions we talked about data collection, the importance of it, and how technology has become such a big deal in agriculture. I'm going to let Dan even expound on that further.
Thank you. It's really great to be with you. Just a little bit of a personal background. I'm an Iowa farm kid and land grant grad, and then wholesale fertilizer for a couple years, and then retail for 8 years. So I was advising and selling to farmers, and then left that and started did 8 years in public affairs, representing the fertilizer and chemical industry, and merged it with Grain and Feed, the Agribusiness Association. And then left that to start doing business consulting, and that led to the creation of Premier Crop 19 years ago. So this is just, I had found this in an archive. This is me at an early age, back in those lobbying days, and that's Chuck Grassley, and sometimes I'm stunned at how much he's aged. This is how we describe our company, and our mission is to help growers and their trusted agronomic advisors create value out of the data they've been collecting, and by converting that data to decisions to drive better economic and more sustainable decisions. We started in '99, so 19 crop year. We market through advisors who would work with growers locally. We describe ourselves as an agronomy company that looks like a software company. It's all web-based software, which kind of gives us unlimited geography, and we continue to expand as the crop mix that can the crop mix expands. But we're really focused on crops that have a yield file, meaning that the combine, as it goes through the field, is measuring yield spatially and collecting yield. And we use that. We've really built a lot of the company on using the yield file to measure whether what we did agronomically was the right thing to do. And we can put any layer in the system: economic, weather, agronomic. A lot of our customers are wildly successful. They're leaders in this space and in providing quality advice, and we're really proud to be the behind-the-scenes technology provider for a lot of them. We've grown the company organically, meaning we've just grown by just one customer at a time, and we've just enjoyed this unbelievable retention rate. So once growers and advisors are part of the system, we've just, over a long period of time, the reason we continue to grow is we just have so much repeat business. We did some analytics with customers last year just to track it over all the years, and some of them are at a 97% retention over almost a 20-year time period. As we move into new markets all the time, we find that, and we say this a lot, the GPS technology allows us to measure spatial variability that exists in all this agronomic data across fields. But what we find is that most growers are accumulating notebooks full of maps and hard drives full of files. And the technology with GIS, Geographic Information Systems, and the mapping software and the data that's being collected just allows us to map a lot of different layers. But at some point, when you have enough maps, you want to start to understand what's the relationship between all those maps. And that's really the data file that the maps represent. And so we try to organize the data file into a database structure that starts letting us see relationships that are difficult to see visually. This is an example of a report we've had for years. We call it a top 10 report. The yield map you see in the upper right or upper part of the map is color coded in this way, and you'll see this throughout a few other map slides in the presentation. The bottom 10% of the field is in red. The next 20% is in orange. So red and orange are the bottom 30% of the field. Yellow is the next 20%, so those three colors are the bottom half of the field. And the green from light to dark are the 20, 20, and 10, the top half of the field. On the table on the upper right, you'll see just yield by soil type, and sometimes that's a significant stopping point, and you can just simply have a discussion with the grower and the advisor just about the differences that exist within the yield file because of soil type variability. In the correlation table, we're just trying to give the advisor, as they talk with the grower, a glimpse of what might be impacting yield variability in that field. And I just highlighted that soil tests phosphorus and potassium in this field showed highly correlated. And the tables that exist in the bottom are just this collection of data tables that come, all those maps represent, organized into a fashion that starts to let people get a glimpse of what might be going on. The table is organized the same as the yield map, so the bottom 10% of this field, the bottom 10% of the acres, 15.3 acres out of 153 acre field, averaged 225 that year. The top 10% was 273. As yields went from 225 to 273, soil test fertility on phosphorus went from the mid-20s, 30, 50, 60. Soil test K from 236 to 295. So it just looks as though there's a strong relationship that as you had higher fertility, you also had higher yields. Over here I've highlighted that this is applied fertility. They didn't put any P and K on because it's a super high fertility field. But over here we're tracking pounds of nitrogen per bushel. So for us from the very start, it hasn't been about high yields, but it's about high yields, which are what's economically sustainable for the operator, but it's about high yields as efficiently as possible with the resources we're using. From the very beginning of the company, we thought it was important that we be able to go to the depth that a grower might want to take it, and so we've had the ability to track all the cost associated with crop production in the system and tie that out spatially. So now what you're seeing on this map is no longer a yield map, but it's a cost per bushel map. And so when that yield file hits us in the fall of the year, we're able to turn around and tell the grower exactly what their costs were. And this is different than other solutions you may have seen because we're actually tracking on a 60 foot by 60 foot basis everything that happened within that field. So if the farmer variable rate seeded the field, put different seeding rates on throughout the field, we're tracking the seed cost as the planter goes across the field. If they variable rate apply lime or nutrients, we track all of that cost. So now what you're seeing on the map is cost per bushel, and the dark green cells are the low cost and the red cells are the high cost. Here's just a table with different hybrids, different seed costs, different cost per bushel, and then it's all summarized down at the bottom for the grower. So we have, and you can see it's summarized here, but you can see it's for a lot of growers, including some that are on the panels, this is just really powerful information. And for us, it's about helping the growers manage this investment they make every year in modern crop production and be able to track all the detail and make the best possible decisions. I always tell audiences that this is the most important slide in the slide deck because it tells you everything about how we started and built this company. When I got out of Iowa State and went to work for a wholesale fertilizer company, somebody put one of these on an overhead projector. Sarah, overhead projectors were like teachers used them. You put a thing on it. So they put this on an overhead projector, and the message of the rain barrel was that it was our job in RealWorld Agronomy to figure out what stave was yield limiting. In other words, it didn't make any sense to manage one nutrient at a high level if another nutrient was yield limiting. It's kind of why you would soil test. But the problem was at the time, the problem was it was on an overhead projector. You couldn't do this. But the problem at the time was that nutrients aren't always what's yield limiting in a field. And so what we try to do is embrace the real world complexity of agronomy, which is just thousands, and modern crop production, it's just thousands of interactions that are going on at once. And so we try to build this comprehensive, most complete database we can, because we know it's not one thing that matters, it's the combination of all these different things that matter. And so even that rain barrel with the staves it has, this is just a fraction of the total staves. And so there's just hundreds and hundreds of layers that matter. Joel Coletti at Iowa State was the associate dean. I think John bumped him out or pushed him aside. Okay. But Joe made, yeah, but Joe says that something to the effect of, real world agronomy or real world crop production isn't rocket science. It's way more complex than rocket science. And I agree with him. So because of that appreciation for real world agronomy, way before we had a big database with millions of acres in it, we built a deep database, because again, it wasn't one thing that mattered, it's all these things that matter and all these different interactions. So it ends up being hundreds of layers deep. Typically in most fields, we build a database and we kind of aggregate the data a lot of times at a 60-foot cell level. This is a Photoshop, got up above the sprayer and just Photoshopped a 60 by 60 area in the field to give you kind of the scheme of how it looks. It's roughly 1/10 of an acre. So in a 100-acre field, we would have 1,000 times that we observed yield by all those layers of data. And a grower with 3,000 acres in the system would have 30,000 data points or observation points. And then we have customers in a local market that would have 100,000 acres. So all of a sudden, when they access the data, it's 1 million observations, and it becomes cumulative. So it becomes 5 million over 5 years. So when people talk about big data in agriculture, this is kind of what we've been doing. We sure would never have called it big data. We just call it trying to do good agronomy. So every year our customers and our growers and your operators, if they're participating in the system, would build a database file. This puzzle slide makes it look really easy. It's not. There's just a lot of really hard work to get great data. There's a lot of people criticize the quality of yield data, because a lot of farmers, the truth is, they don't necessarily pay attention to calibrating their yield monitors. But I would say, in those growers' defense, if you've never used your yield data to make a decision, pretty soon you quit caring. But what we've found is that once they're paying an advisor to advise them in using their data, and once they're writing a check every year to be part of a system like ours, all of a sudden they care about quality. And so they really spend a lot of time making sure that we get the data right. And so every year we would probably get about 8 layers of data, 8 layers of the 400 off of a yield file. 52 of them are the aggregated weekly GDUs and rainfall. 15 could come potentially from the planting file. 12 or so potentially off the soils. Up to 20 some off of a great soil sample. And there's 20 or 30 tied to applied fertility. And then there's hundreds of others that are collected in other software, and sometimes it's just an interview with the operator. There's a lot of things that aren't captured on a device. So we just organize the data into a database structure that lets you see relationships, and the analysis starts at a subfield level and goes across the grower's operation. And we as a company from day one have signed off that the grower and the landowner own the data. It's collectively for the benefit of the growers who participate, and we believe that the knowledge that's created off that data is also theirs. Correlation doesn't always equal cause and effect, so big data analytics aren't traditional for ag. This is my example of me right out of college, and that would be a perfect correlation, but I can't prove cause and effect. But Greg asked me. Greg has seen this, dozens of times. Greg, where is Greg? Where's he at? He left? Okay. He's seen it before, so it's okay for him to leave. Great, there he is. he has this unbelievable resume. Unbelievable resume. I mean, seriously, he headed agronomy for a big piece of the country for Pioneer. And yet I heard in your presentation you invoked the name of the Pope. It's like your resume wasn't good enough, you had to bring the Pope into it. You couldn't just build your case. Yeah, the Pope said you should do this. This is a table out of a grower report, and this grower had 1,700 acres of soybeans. But one of the points that Greg wanted me to make as it relates to land ownership is that part of this stewardship message is that fertility matters. That fertility matters, and managing organic matter and fertility in your farm matters, and it affects the productivity. And Greg knew I had a bunch of data that looked like this, so if you just follow this slide, this is a grower who has 1,700 acres of soybeans in the system. This is just one table out of a dozen tables in a report, but this is the one that summarizes their soil sample data across all their operation and their yield data. So just follow with me. As yields go from 42 bushel per acre on the low 10% to 73 on the top 10%, soil test fertility on phosphorus goes from 18 to 37, soil test K from 171 to 222. This grower has 4,100 acres of corn in the system, almost 4,200. The bottom 10% of all those acres, his lowest yielding 400 acres, those 400 acres weren't in individual fields. They were all, those 60-foot cells spread across 400 acres from all these different fields. But those 158 is the bottom 10%, 263 is the top 10%. Soil test P goes from 19 to 31, K goes from 160 to 243. So when Greg talks about, this is 4,400 acres of corn, 150 to 250, or this is soybeans, 39 to 68, 20 to 30. So when Greg was making his pitch there and he's talking about why you should care, it's just he knows that this is data that shows that that it does matter. And now that I just showed a whole bunch of relationships where the highest yields were coming off of, I just showed a whole bunch of data where the highest yields were coming off the higher fertility parts of these farmers' operations. But for most of you, if you saw data in Premier Crop, if your grower has not been doing all this activity I'm talking about, and they've been just farming the way everybody's been farming for years, their data actually looks closer to like this when you see the relationship between yield and fertility. 27 on the bottom 10%, 55, but look at the fertility, it's just the opposite. The high fertility is the lowest yielding. Look, goes 216 down to 162, 36 down to 21. So, and why that happens is that for decades, people have been doing uniform applications, been putting the same rate of nutrient on every acre. We just had, but the yield, we haven't been removing it uniformly. So the the consistently high yielding parts of the field, they've pulled down the fertility. And the low yielding parts of the field, the fertility is sky high because they never produce a crop. They're the drown out spots. In north central Iowa, it's the potholes. You go to north central Iowa, you see this all the time. It's those potholes. They're organic matter rich and they're nutrient rich because 8 years out of 10, they have a short crop because it's too wet. 2 years out of 10, they're the highest yielding part of the field because they're so darn high in fertility. But it doesn't make any sense to keep uniformly applying nutrients to those spots, does it? So a lot of times when I talk to operators and I talk to growers about why you would do this, it's not about saving money. It's about reinvesting this investment they make every year in nutrients and seed more efficiently and more effectively within the field to try to generate a higher return. Greg also asked me to talk about this. This is just a benchmark tool that Premier Crop has. So these are three different, I'm going to show you 3 different growers' operations. We just call this index. We divide we kind of divide yield by, or we divide pounds of N per bushel, or we divide yield by pounds of N per bushel. So anyway, it gives us this calculation that relates to nitrogen efficiency. So if you follow me, this field was average 213, and they produced that on 0.89 pounds of nitrogen per bushel produced, and it yields an index of 242. This one's almost identical yield-wise, 212, but it took them 1.33 pounds of nitrogen per bushel, so the index goes down to 161. And then this is what we're really after. They produced 215 on 0.71 pounds of N, so the index climbs to 306. So it's just a way. The whole point of all that is for us, it's not about just high yields. It's about squeezing every bushel of grain we can out of every pound of nitrogen we apply. So it's just about being as efficient as possible. Since 2005, part of our growth as a company has just been from helping growers drive variable rate seeding prescriptions. So I just saw a news headline flash on my screen earlier this morning that said seed prices have tripled in the last 20 years. So some of you who may have retired from farming back a few years ago, seed prices have escalated dramatically. And so managing that seed investment, which just continues to escalate within the field, is just a bigger and bigger value. And so a lot of these growers have invested. Everybody know what auto steer is? Auto steer, just, the GPS in the tractor steers the tractor, steers the combine, steers the sprayer, steers everything as they go across the field. It's just, I'm not really big on the idea that we're going to have driverless tractors and driverless cars and all that, but the same as we're talking about driverless cars, that technology is in the cab. So there's a whole bunch of operators who, they love auto steer, so they have auto steer in the cab. Well, when they got auto steer in the cab, most of the time they got variable rate seeding capability, so they're able to change plant population on the fly. And so the question is, how do you do it? And we just have a great solution, kind of a real simple message. We talk a lot to growers about dividing their fields into management zones. We call it ABCs just because it connects with everybody and that dreadful getting a report card. But the A zones are the best part of the field, the consistently highest yielding parts of the field. For us, A zone also stands for the part of the field where maybe you're willing to be more aggressive. So it might be the part of the field you could step up the plant population a little bit. B zone's kind of field average, and then C zone becomes the area where it probably makes more sense to be conservative. So it's kind of a simple solution. We have a great solution that's very visual, where we just use this. We use historic yield maps. So there's a lot of growers who have just been collecting yield data forever, and we just have a real simple way. And you can start to see, as this is multiple years of yield data, and you can start to see the spatial trends in yield, and you can pretty well darn pick out where the A zones are going to be and where the B zones and C zones are going to be. So this message kind of makes sense to growers. It kind of makes sense that I'm not going to plant the same population across the whole field. And so they might, if they're planting 34 today, they might plant 36, a couple thousand more in the A zone and back off a little bit in the C zone. I've been in agronomy since I left Iowa State a couple of years ago. And I have never sold anything as popular as what I'm going to tell you about right now. In 2005, we started doing this. I put check blocks inside the prescriptions. And so I wanted a way to validate to the grower that variable rate seeding paid. And we trademarked that as learning blocks. So a learning block is a 1 or 2 acre comparison area inside the field. The reason growers love is they get feedback. So if I'm planting 36,000 in the A zone, I might plant a 1 acre check of 39,000 and a 1 acre check of 33,000. And then we just automated the process. So we do this now with plant population, but we do it with, and so once they get the report back, it gives them the analytics, The learning blocks are kind of summarized in tables like this: a 3 bushel advantage for 35, or 3 bushel advantage, or a 3 bushel difference, 35 versus 37, so actually a lower population paid. Here, a little bit higher nitrogen gave them an 8 bushel yield advantage. So the learning block concept, we do it with everything now, so it just opens the door to use the technology. So think about what we're talking about. The grower is not slowing down the operation. He's planting the field just the same. The technology and the equipment is changing the rate as it moves across the field. The nutrients change as it goes across the field. Everything is automated. They don't slow down harvest. It's not a weigh wagon. It's not a test plot. It all happens on the fly as they go across the field. We've done a lot of strip trials in the past, and then what we realize is that sometimes we were running that strip of high population across the best part of the field and into the worst, and we averaged the results of the strip, and we didn't get a big yield increase, and part of it was just because even if we divided it out by soil type, we still sometimes lost the advantage. We as a company talk a lot about agronomic synergies, and one of the things that we talk a lot about with variable rate seeding is matching the nutrient piece to the seed piece. So if we're going to push populations, we need to make sure we have adequate plant food, and if we're backing off, then that maybe creates an opportunity for savings. This is just a slide that was shared with me that is root mass in a 30-inch row by population, and you see from the right to the left, the corn plant gets the smaller root mass as you get higher population, just because we continue, this modern genetics allow us to push populations, but it also means you have a smaller root mass. So in our A zones, we probably have to make sure we adequately feed them. In the C zones, a lot of times the reason we get a yield increase from decreasing population is you actually give the plant a little bit more space, bigger root mass. A lot of the country, the C zones are lighter soil types. They're eroded, they're eroded side hills. So the message on the C zone is matching your expectations and your input dollars to that part of the field. Our food metaphor for it is if you invite more people to dinner, you need extra food. We have tools that allow people to benchmark their field versus group data. So this is a tool called Optics, and this is a 700,000 acre group of corn data, and here's where the field, here's where this guy's field is compared to the group. And then it not only allows you to know where you are compared to the group, but it allows you to know why you're there or what you could do different. So there's a whole bunch of filters. So you could look at, what if I planted earlier in a higher population? What does that do to the distribution of yield? What's my favorite hybrid or trait package? So it just allows you to play with the tool. So it's not just how am I doing, it's why am I doing. We also have reports like this and just these massive databases where people can access this high quality data. And so sometimes yield by hybrid is interesting. So here's 700,000 acres of yield by hybrid, but if you stop to think about it, wouldn't it be more powerful to know yield by hybrid by similar soils as my farm? And we can do that, and here's 288,000 where it's yield by hybrid by the same soil type. But then you start to think about, well, you had a whole bunch of slides that said fertility mattered, so how about yield by soils by soil test fertility? And now I've reduced that 700 down to 37,000. And so you just keep going and going. And so the power of the data is not these big data sets, it's being able to slice the big data sets back down to data that just matches exactly as best possible your field. And that's what this report is. We pay attention a lot and are heavily involved in trying to lead our growers to be as sustainable as possible, and a lot of them are really, really sophisticated business people. I am blown away by how many millions of dollars it takes to run some of these farming operations. Just this vision that modern farm that farmers are. It drives me crazy when the public thinks that farmers aren't sophisticated business people. They manage incredible amounts of risk. They manage huge budgets. I mean, just literally millions and millions of dollars. So this is big time business management. They're really sophisticated people. They don't make decisions on a whim. But we in agriculture, you know, we need to continue to do better. And part of that doing better is just being serious about meeting challenges. And one of those challenges is clearly around nitrogen. And we as a company hope that we're going to have a solution that will help us with nitrogen. I think sometimes in agriculture we have a false sense of how much we know. And I'm going to use this example. I'm a big land-grant fan, a big Iowa State College of Agriculture fan. It drives me absolutely crazy that universities' fundraising is tied to athletics and not their ag schools. You know, so for me, I could care less what the football team does. I care a whole bunch about the grads that are coming out of the school. So this is a article that was in Successful Farming a couple of years ago, and John Sawyer, the Iowa State soil nitrogen specialist, is talking about the N-rate calculator database. So the N-rate calculator database is kind of a combination of 7 Midwestern states that threw all their nitrogen data together. It's, in my opinion, it is the largest nitrogen rate database in the world. In my business, what's changed is, you know, we're 19 years into this, and all of a sudden, all the big companies are jumping into this data space. And they all have solutions. They all have solutions where they're going to tell the farmer, you know, the farmer's supposedly going to buy a script from them, and these big companies are going to tell the farmer how to manage everything, including nitrogen. But the universities, the truth is, the universities are the ones that have all the response data, and everybody's building predictive models off of those data sets. But I just want to highlight part of what was in the article. And John said we have over 1,500 N-rate yield response trials from 7 states. 90% have come from the last 15 years. This is just an example where one of the big companies is citing that that's what they're using for their database. So the largest nitrogen response database in the world is 1,500 trials over 15 years, 7 states, 90% in the last 15 years. So 1,350 divided by 15, divided by 7 states, is about 15 response trials per state per year. So for me, the future of farming is what I'm going to talk about right now, and what we're really excited about sharing as a company. So I got involved in this whole thing of using data to make decisions because I wanted to do better. I felt like there was so much room for us to do better. But the other thing that scares me to pieces is the idea that agriculture could be regulated on a one-size-fits-all solution. So I'm on the road a lot. The road a lot, and I just want to share this as I get ready to close here. Every Friday, if I'm on the road, I listen to Ira Flato and Science Friday on NPR, and I caught one of these, and he was interviewing these people about fruit flies and human cancer, and I was just fascinated. So then I looked it up as he interviewed this author, and so the title at the top is "Can Precision Ag? Can what Premier Crop does become agriculture's fruit fly?" So fruit flies share a lot of our common genes, and so what scientists have figured out is that they can reproduce cancer cells into fruit flies, and then researchers can order up different versions of fruit flies and do replicated trials with cancer drugs to see which one is most effective on which gene. And it is fascinating, and it's going to lead to personalized cancer treatments. And this summary here is the beauty of the detailed fruit fly experiments is that they tackle real-world complexity of malignant tumors rather than having to simplify everything and treating all cancers like they're alike and then disappointing when the results aren't predictable. So instead of a cocktail of chemotherapy, we're going to get tailor-made drugs that solve the specific cancer we have. And so for me, the key going forward is, can we quit treating every part of every field as though it's the same when it's not? And so the history of everything that's happened so far is that we've taken data and knowledge that was created somewhere else, and we've converted it, or we've applied it spatially within the field. We just announced yesterday we're rolling out this product we call it enhanced learning blocks. So the same learning block idea that I just talked about, this is kind of a little video that helps you understand it, but what we've added to the learning block thing is now we're able to do randomized replicated trials on the move, and this is kind of how it would work as you see the video. It requires that the equipment has to be set up right, all the technology, but it's now you see the planter go across the field. Up at the top is the monitor that the grower would see in the cab, and as they're going across each of these different replicates, it's changing the rate. The reason this is so important is in that earlier slide when I said correlation doesn't equal cause and effect, big data analytics can never answer that cause and effect issue. But I'm a student, I didn't do great at Iowa State, but I paid a little bit of attention. And this experimental design that is randomized replicated trials, it's the foundation for science. It's the foundation for knowledge creation. An FDA drug trial, right before it, the last stage is a human trial where one group gets a placebo and one gets the real thing, and it's a replicated study. But most of agronomy is built on this replicated trial model. And what we're excited about is being able to have made the changes in the software and a whole bunch of behind the scenes work to be able to scale replicated trials and hopefully create knowledge at an unprecedented level. So a single grower, to contrast this to 15 trials per state per year, with enhanced learning blocks, a single grower with 30 cornfields could do 3 enhanced learning blocks per field. A single grower could have 90 replicated nitrogen response trials in a single year. If you partnered with 10 other growers in a local market, we could have 900 trials just in a local market. If there's 25, think of a local market as 4 counties in Iowa, and there's 25 of those in the state. We look forward to the day when we're going to be producing 22,000 replicated trials in Iowa a year. And over 3 years, all of a sudden, it's just thousands and thousands. So for a whole bunch of growers who love their land grant and they want to partner with their land grant, this is going to open the door for knowledge creation at just an unprecedented level. We're excited about the future of all this. We believe it's going to lead to more sustainable and economically sustainable agriculture. Thank you.
Time to take about one question before we move on to our 1 o'clock session. Sheila.
I'm just curious whether any of the discussion revolves around those C identified areas, the low yielding, of just making them fallow rather than planting at all.
It does. Ag Solver, a company in Ames, got a lot of traction by promoting the idea of just enrolling those in CRP, and I think that's makes total sense. So it's part of that cost tracking. What we're doing different than Ag Solver, though, a lot of times Ag Solver takes whole field yield. They take whole field input cost and divide it by the yield file. And what we're doing is actually tracking. If I invested more in seed or I invested more in nutrients, we're tracking. We're not taking that on a whole field and just dividing it by the yield file. We're tracking every single cell uniquely. So.
Okay. Well, time for one more quick question. If not, let's thank Dan again.